Hello everyone and welcome to the 6th episode of C++ Next. In this episode we will wrap up the Reentrop-Cast story, and I will showcase my header library called SafeCast. With this library you will be able to cast any number or object safely to any other number or object. In C++20 we got bitcast, which is a safe way to Reentrop-Cast objects from one to another, because it starts the lifetime of an object and it copies its bits from one object to the other. But this has one small downside, as you can see. The types have to be the same size. Because the types have to be the same size, we cannot copy different sized objects from one to another safely, and we have to implement it by ourselves. And this is exactly where my library comes to the act, as it will do the work for you. It will cast from any size to any size correctly, and even from buffers to an object. Let's look at the next example. Let's say that we have a hardware that we need to simulate. The hardware can work with floats or ints, but during the computation stage, it must work with uint64. So someone might write the function that we wrote here that looks fine because we are using Launcher and we are casting from float to bytes and from bytes to uint64 and then returning the actual number. But what is the actual problem here? Think about it. Float is 32 bits. We are turning 32 bits into 64 bits. That means that we are copying garbage that might have been in the memory where f was residing. And that means we will not get the correct number that we're expecting. We will not get padding of zeros. And that means this is a total undefined behavior. To make this example a little bit clearer, I want to show you what exactly I mean. If you would look at line 13, you can see we have a float that is 5.3. If we are Reentrop-Casting it to uint32, we will get this number. But if we are Reentrop-Casting it to uint64, we will get this monstrosity. This is absolutely not the same numbers. Each time we will run the program, we will get a different result because we have something else in the memory and f will reside in a different location, and that's why it's problematic. But then someone may come and say, well, we don't need to work with Reentrop-Cast, we don't have to be that extravagant. We can use Staticast here. And the answer is no. Staticast will not work here. You have to remember that Staticast will actually trunk the number from float into uint64, and that's not what we want here. We want to keep working on the same bits as before without truncation, and to look at the number that those bits represented in uint form. So Staticast will not work here as well. What we really want to do here is to work with bitcast. But sadly, bitcast will not work here because float is 32 bits and uint64 is 64 bits. So the functionality will not work out of the box. Instead, we will have to write this. Now, all we need to do is to include the SafeCast file. We can change all of this functionality to just something really simple. And that's it. As you can see, the result is the same number, exactly what we wanted, and with a very simple implementation in your code. In the backend, I detect the sizes, I decide what should be done if it's int or unsigned int, and all the types will work for you. Now, let's look at another example. Our favorite example for the entrepcast is when we are getting bits from the network and we have to re-entrepcast it to something else, or basically turn it to a real object. So with my library, you can do that as well. Let's look at the code. What do we have here? Basically, the function receives an array of bytes, or chars in this case. Then we are just calling the function bitcast. We are telling it we want to translate what we got from the network to float. We want to have an offset of 6 characters or 6 bytes inside the buffer because we know the float is 6 characters away. Then we are saying buffer's kind is char or char. And then we're saying the size that we want to copy is 10 because we need it to be 4 bytes in this case. Then we are taking the bytes and providing it in. This function works on arrays or on any byte-like container. So as you can see, it's really easy. And if we are providing something from the network, let's say, and here we can see this is the representation, the hexadecimal representation of 5.3. And if we will use the function, we get exactly what we want. My float is 5.3, safely translating bytes from the network to the types that you need. Thank you for watching. Next month I will be attending CppCon and I will be presenting my talk about signed and unsigned integers. Everything that can go wrong when you use the incorrect type for the job. So if you're in Denver, come to CppCon and of course come to my talk. See you in the next episodes, and as always, like and subscribe. Thank you.